Hello students, welcome to the class, and this is the third lecture on the topic electrostatic. And here in this unit electrostatic will deal with what? Coulomb's law. Okay, this is a very basic law. What does the law say? According to Coulomb's law, the force of interaction between 2-point charges, you have given 2-point charges, right? And these 2-point charges are kept r distance apart. Then the force of interaction acting between 2-point charges, right? This force of interaction is directly proportional to product of the charges and is inversely proportional to square of the distance between the charges. Okay, and when you write it together, you will write F proportional to Q1 Q2 by R square, which further may be written as F equals to beta Q1 Q2 by R square, where this beta is what? Constant of proportionality. Beta is constant of proportionality. Generally we take constant of proportionality as K, but for a reason I am taking this as beta, right? Okay, and be careful, all the constant of proportionalities depends upon two things. First, on the system of units in which you are having the measurement, and secondly on the medium between the 2-point charges. So here we will deal this Coulomb force by observing the values of beta in different system. What will be the value of beta in SI system? What will be the value of beta in CGS system? What will be its value in CGS in medium, CGS in vacuum? Let us go through that. And in that way, when you define this beta in different way, you will have different forms of Coulomb's law, Coulomb's force, right? So first, value of beta in CGS system, in CGS, ESU, electrostatic unit system. In CGS there are two systems, electrostatic unit system and electromagnetic unit system, ESU and EMU. So here we are dealing with the which system? CGS ESU, electrostatic unit system, right? And in this system we'll study the value of beta first in medium. Means if you have certain medium between the 2-point charges in the whole space, then what should be the value of beta there? What is our force there? I am writing there beta Q1 Q2 by R square. That is our force, right? And here we are observing the constant of proportionality beta. So this beta in medium in CGS system is what? 1 upon K. Okay, therefore I have not taken this beta as K. What is that K? Beta is 1 by K, where K is called what? Dielectric constant of the medium. Dielectric constant of the medium. Therefore, the force would become what? When you take beta as 1 by K, this force would become F equals to 1 by K Q1 Q2 by R square. Dine I should write, because we are dealing the beta in CGS system. So force would be written also in CGS system, and the unit of force in CGS system is what? Dine. Secondly, when you observe the beta in vacuum, what will be that? So in vacuum, K is 1. Dielectric constant in vacuum is what? 1. Also in air medium, the value of K is 1.00059, which may be taken nearly equals to what? 1. So in vacuum or in air, you may take this K as 1. And when this dielectric constant becomes 1, then beta would also become 1. When this K becomes 1, this beta would become 1, and the force would become what? F naught equals to simply Q1 Q2 by R square. Because this K becomes 1, so force will be Q1 Q2 by R square dyne. Here we have taken this force as F naught. Why F naught? Because we are observing the force in vacuum. So here we have a very special what forms of Coulomb's law. In CGS system in medium it is 1 by K Q1 Q2 by R square dyne, and in CGS system in vacuum is Q1 Q2 by R square dyne. Beta is 1. Constant of proportionality here is 1. Right? Now from here you can see a very important result. In vacuum the force is simply Q1 Q2 by R square, but when you take the same charges, same distance apart, the force would decrease 1 by K times. How? Because the force becomes 1 by K Q1 Q2 by R square. Force becomes 1 by K times when you take the charges in medium. Also, you may write here a very important thing. F naught upon F equals to, what will you get there? F naught upon F. F naught Q1 Q2 by R square. What is that? F 1 by K Q1 Q2 by R square. This Q1 Q2 by R square cancels out and you get this as K. Very important result. So F naught by F is found to be K. So here you can define the dielectric medium of dielectric constant of the medium. Here you may define dielectric constant of the medium. How? Dielectric constant may be defined as the ratio of force between 2 point charges in vacuum to the force between same 2 point charges kept same distance apart in medium. So ratio of force between 2 point charges in vacuum, okay, to the force between same 2 point charges same distance apart in medium is called what? Dielectric constant of the medium. Okay, so here we are dealing with what? The force and in different system of units in medium, in vacuum. So this we have taken, we have studied the value of beta in CGS system. Now let us move to the next system. What? SI system. What would be the value of beta in SI system? So in SI system and in vacuum, in SI system and in vacuum. So second is SI system. In SI system and in vacuum, beta is taken to be 1 upon 4 pi epsilon naught. These all constants were suggested by Sommerfeld. Okay, Sommerfeld was the best teacher of the world, whose 13 scholars they got Nobel Prize, right? So these are the constants suggested by Sommerfeld. So 1 upon 4 pi epsilon naught Q1 Q2 by R square. Sorry, beta is 1 upon 4 pi epsilon naught, where this epsilon naught is called permittivity of vacuum or free space or air medium. Okay, and this epsilon naught is experimentally found to be 8.854 into 10⁻⁻12. So when you take this beta in vacuum as 1 upon 4 pi epsilon naught, then the force would become what? 1 upon 4 pi epsilon naught Q1 Q2 by R square Newton. Okay, so in SI system in vacuum, beta is 1 upon 4 pi epsilon naught, where this epsilon naught is called permittivity of free space, absolute permittivity, right? And about this we'll study afterwards. Actually, if I say that permittivity epsilon naught is the ratio of electric displacement to the electric field intensity, you will not follow it at this stage, okay? While dealing with the dielectrics, we'll be dealing with the definitions of this all, but just this time you just go through that this epsilon naught is certain constant, which is what permittivity, it is called what? Permittivity of free space, and its value is what? 8.854 into 10⁻12, okay? And from here you may write its unit also. How? If you take this epsilon naught this side on the left hand side and force towards the right hand side, you will get Coulomb square, charge Coulomb square per Newton per meter square, Coulomb square per Newton per meter square. So epsilon naught, when you taken to the left side, you will get the force, the unit of epsilon naught as Coulomb square per Newton per meter square. Okay. Now further, if I take substitute here the value of pi and epsilon naught, you may obtain this 1 upon 4 pi epsilon naught as 9 into 10⁻⁹. So the force would become what? F naught equals to 9 10⁻⁹ Q1 Q2 by R per Newton. So this is the value of beta in SI system in vacuum. Now next, value of beta in SI system and in medium. Okay, so in medium, so in SI system and in medium, this beta is taken as 1 upon 4 pi epsilon. Here it was epsilon naught, there it is what? Epsilon. What is that epsilon? It is the permittivity of medium. So therefore the force would become what? F equals to 1 upon 4 pi epsilon Q1 Q2 by R square Newton. Earlier in vacuum it was 1 upon 4 pi epsilon naught. Now in medium it is 1 upon 4 pi epsilon Q1 Q2 by R square. Further, we define epsilon upon epsilon naught. Okay, epsilon, the permittivity of medium, upon epsilon naught, the permittivity of vacuum, as relative permittivity epsilon R. What is that? It is relative permittivity. Relative permittivity, which is dimensionless, unitless, because it is a ratio of permittivity of what? Medium to the permittivity of what? Vacuum. So it is a quantity which is what? Dimensionless, unitless, epsilon R. And from here you may write what? This epsilon as epsilon naught epsilon R. Also you may write this as epsilon naught K, because K and epsilon R are equal. K means dielectric constant. So finally in medium, in SI system and in medium, you may write the force as what? 1 upon 4 pi, instead of epsilon you may write what? Epsilon naught epsilon R Q1 Q2 by R square, the force. Also you may write this as what? 1 upon 4 pi epsilon naught K Q1 Q2 by R square, because epsilon R and K are what? Equal. You got the point? So in that way you have written the Coulomb force in 4 forms. First form, in medium and in CGS system, 1 by K Q1 Q2 by R square dyne. In CGS system in vacuum it was simply Q1 Q2 by R square. In SI system and in vacuum it was what? 1 upon 4 pi epsilon naught Q1 Q2 by R square. And in SI system and in medium it is what? 1 upon 4 pi epsilon naught epsilon R Q1 Q2 by R square, or 1 upon 4 pi epsilon naught K Q1 Q2 by R square. Because you may write this epsilon R as K. Is that clear? So this we were dealing with what Coulomb's force in different forms, right? Now after that we will be dealing with the very important properties of Coulomb's force, right? So what are the important properties of Coulomb's law? What the properties what characteristic this Coulomb force shows there, right? So next topic is what? The properties of Coulomb's force, Coulomb's law. So what are the important properties? The first property is what? That the Coulomb's law holds good only for the point charges. Okay, the Coulomb's law, it holds good for what? Point charges. The first property is what? The first property is what? That the Coulomb's law holds good for point charges. Now this, it's very clear that when you take the point charges at certain distances r, then the force of interaction is 1 upon 4 pi epsilon naught Q1 Q2 by R square. Exactly. So that time actually when we say this as point charges, the distance should be very much larger than the size of what charge. Okay, then you can take the charges as point charges. So it is strictly given for what? Point charges. If you take somewhere a rod having some charge and a point charge here, you can't write the Coulomb force, Coulomb's law for this case, right? You will have to treat it in a different way that we will study afterwards. So this important property which says you that Coulomb's law holds good for point charges can be very well followed by this question. There is a good question in Cengage. In Cengage, there is a good book, Cengage, which is especially referred for JEE students, right? There, with the Cengage, you get some DPPs also, right? So in that DPP, there is a question number 8, right? And that question is very innovative question, a new question. What does the question say? You have given two identical spherical bodies which are kept nearby. They are not kept very large distance apart. Okay, they are kept what? Nearby. And suppose you give these identical conductors same charges Q and Q, like charges. You better know that they will repel one another. Say they repel each other with a force what? F1. Further, when these spheres, same spheres, are given unlike charges, Q and minus Q this time. Earlier, they were given what? Q and Q, like charges. So they are repelling one another with force F1. Now after that, this same identical spheres, metallic spheres, are given now Q and minus Q charges. Now they will attract one another. These two will what? Attract one another. Now the question is what? What do you say about these two forces? Whether the forces will be equal or F1 greater than F2 or F2 greater than F1 or none of these. What would you predict here? What do you say? The job is very simple. Be careful. It is strictly given for point charges, but these are not point charges. These are some heavy bodies, right? Because the separation between them is small. Okay. So here, when you think of the charges, as these two charges are like charges, they will repel one another. And instead of the charges distributed uniformly, generally what happens when you take a single sphere, and when you give charge to this metallic sphere, this charge resides only on the surface. That we have studied in the first lecture. Okay, that the charge when given to a metallic conductor, it resides uniformly over the surface of conductor. But here, as there are like charges, these charges will repel one another, and due to the repulsion, what will happen? The separation which should be R, it becomes greater than R. Why? Because the charges when repel, their centers will move away from one another. If you think of this case, the center of the sphere and the center of charge coincides. But here, what will happen? Due to the repulsion, like charges, when they will repel one another, their center of charge would be different than this geometrical center. ये चार्ज का सेंटर इधर चला जाएगा, वैसे इस चार्ज का सेंटर इधर चला जाएगा, क्योंकि चार्ज रिपेल हो गए, दूर चले गए, तो ये F1 कम हो जाएगा. On the other hand, when you think of these charges, इधर पॉजिटिव चार्ज अट्रैक्ट हो जाएगा, इधर आ जाएगा, इधर नेगेटिव चार्ज है वो अट्रैक्ट हो जाएगा, and due to this attraction, their centers are coming to nearer. So F2 will be more. Okay, when you just measure these two forces, what is happening? You are just thinking that the distance between them is R, but actually due to the repulsive force, when the charges move apart from one another, the distance between them becomes more than R here, and here the distance between them becomes less than the R. If the centers are separated R distance apart, the charges are separated lesser distance than R. Okay, so here F2 would become greater than F1. So what should be your answer there? C. So be careful when you are not taking the point charges, the result is different. Okay, you would have been thinking of this answer, F1 equals to F2, but that is not the case, as these are the bigger objects, bigger bodies. We can't take them as point charge because the separation between them is smaller as compared to their radius. We can't take them as point charges. So we have to deal them it differently. And the answer instead of F1 equals to F2 is what? F2 greater than F1, because due to the attractive force, the charges are coming closer and increasing the strength of force. Is that clear to you? Now after that, next, second property. Property number 2. What is that property? Coulomb force acting between 2 point charges. Coulomb force remains unchanged if a third charge is brought nearby. Right? So if you have 2 point charges, Q1 and Q2, and these 2 point charges, they repel one another with the force F and F, and suppose you bring a third charge or a fourth charge or a fifth charge nearby, then the force which these two exerts upon one another, that would be unaltered, unchanged. The force will remain same. हाँ, ये हो सकता है कि ये Q3 Q1 पे फोर्स लगा, Q1 Q3 पे फोर्स लगा, Q2 Q3 पे फोर्स लगा, Q3 Q2 पे फोर्स लगा, ये आपस में फोर्स लगाएंगे, लेकिन उनके बीच का फोर्स जो है वो क्या होगा? चेंज नहीं होगा. Okay, so be careful about this property, that the Coulomb's force acting between 2 point charges remains unchanged, unaltered if you bring a third or fourth or fifth charge nearby. Now next property. Next property says you that Coulomb force is a mutual force. Okay, Coulomb force is a mutual force. What is the meaning of mutual? Mutual means the two charges, they exert equal and opposite forces on one another. How? If you have this point charge Q1 and this point charge Q2 at certain distance are apart, the force which the Q1 will exert on Q2, force on 2 due to 1, and the force which Q2 will exert on Q1, that is force on 1 due to 2. These two forces will be equal and opposite to one another, irrespective of the charges. Whatever charges are there, Q1 and Q2, the charges may be different, but the force, their magnitudes will be same. They are exerting equal and opposite forces on one another. The magnitude of F21 is equal to the magnitude of F12. Okay, the magnitude of F12 is equal to the magnitude of F21. So, therefore, the Coulomb force is called what? A mutual force. The gravitation force is also a mutual force, right? That also you better know about the gravitation force. So, in the same way, the Coulomb force is a kind of mutual force, right? So, suppose in the book Dinesh, there are some conceptual objectives are given, right? And there is a problem in the book Dinesh. What is the problem? He has taken two charges, 2 microcoulomb and 5 microcoulomb. Okay, certain distance apart. And the question says, what would be the ratio of forces the two exerts on one another? ये दोनों चार्ज एक दूसरे पे जो फोर्स लगाएंगे उसका रेशियो क्या होगा? F1:F2 क्या होगा ये पूछा है, और ऑप्शन ऐसे है 2:5, 5:2, 1:1 and none. क्या होगा आंसर? 2:5 की 5:2, 1:1, because whatever are the charges भले अलग अलग हों, लेकिन वो दोनों एक दूसरे पे जो फोर्स लगाएंगे वो प्रोडक्ट ऑफ चार्ज पे डिपेंड करता है. दोनों के प्रोडक्ट के हिसाब से चार्ज लगता है, फोर्स लगता है, राइट? इसलिए याद रखिए ये जो फोर्स है म्यूचुअल है, दोनों एक दूसरे पे बराबर फोर्स लगाएंगे. भले ये 2 है वो 5 है, बट द 2 will exert equal and opposite forces on one another. So the ratio of forces will be what? 1:1, right? So these are the very important properties. Be careful about that. So Coulomb force is a mutual force. The 2 point charges, they exert both equal and opposite forces on one another. Now next property, Coulomb force is a strong force. Strong means as compared to gravitation force. Coulomb force is a kind of what? Strong force. Okay. So next property, Coulomb's force is a strong force. While the gravitation force is a weak force. The reason behind this is what? When you write the gravitation force, F equals to capital G m1 m2 by r square. The value of capital G is what? 6.67 into 10⁻⁻11. 10⁻⁻11 force को कम कर दे रहा है. On the other hand, when you write the Coulomb force, what is that Coulomb force? It is 9 into 10⁻9 q1 q2 by r square. 9 into 10⁻9. What is the value of 1/4 pi epsilon naught? 1/4 pi epsilon naught we have taken as what? 9 into 10⁻9. 10⁻9 force को बढ़ा रहा है. So let us compare. How is the Coulomb force stronger than what? Gravitation force. And there is a very important question, right? In your book NCERT, in page number 13. In this book NCERT, page number 13, there is example number 1.4. That is a good question. Example number 1.4 and NCERT, page number 13. There it is ask you to compare the electrostatic force and gravitational force between two electrons 2 protons and proton and electron, right? क्या किया उसने, क्या पूछा है उसने? 2 इलेक्ट्रॉन लिए हैं और बोला है कि between 2 electrons what would be the force of Coulomb force and gravitation force and the ratio between them. So if you take 2 electrons, electron and electron, certain distance r, and suppose their masses are me and me, then if you write the ratio of Coulomb force, electrostatic force to the gravitation force between them, how will you write there? This will be 1 upon 4 pi epsilon naught Q1 and Q2 by R square. So Q1 Q2 is E by R square upon what would be the gravitation force, capital G, M1 M2, so ME by R square. R square cancels out here and what will you get there? E square upon 4 pi epsilon naught G ME square. Right? Be careful. In NCERT, in exercise, there is question number 2. In that question, it is asked you to write the dimension of this quantity, unit of this quantity. Be careful. The unit of this quantity will be what? It is dimensionless, no unit, because it is a ratio of 2 forces, Newton upon Newton. तो NCERT में exercise में एक question है, इसको दिया है उसने और बोला है इसका बताओ what would be its unit. So it is unitless, force upon force. Okay, now when you put the values of E की वैल्यू कितनी होती है बच्चों? 1.6 10 to minus 19, 1 upon 4 pi epsilon naught 9, G 6.67 10 to minus 11, mass of electron 9.1 into 10 to minus 31 kg. When you put this all values, you will get this as what? Nearly equal to 4.2 into 10 to 42. तो 10 to 42 का order आता है. When you compare the force between two electron and electron, electrostatic force, Coulomb force, and gravitation force. When you take the ratio of these two, the order is 10 to 42. देखिए कितना ज़्यादा है. So Coulomb force is a strong force. 10 to 42 times stronger. 10 to the power 42 times stronger. On the other hand, when you take what? Electron-proton pair. For that, Fe by Fg has the order of what? 10 to 39. And on the other hand, when you take proton and proton pair, that time Fe by Fg is 10 to 36. Okay, so order is what? 10 to 36. So जैसे जैसे आप प्रोटॉन को इंक्लूड करते जा रहे हैं, मास बढ़ता जा रहा है एक्चुअली, इसलिए नीचे का फोर्स बढ़ता जा रहा है, इसलिए ऑर्डर कम होता जा रहा है. Okay, are you getting the point? So be careful. Coulomb force is a strong force, and these examples are given there in that NCERT book, and you can calculate very easily the ratio of electrostatic force to the Coulomb force. What you have to know, the charges and their masses. कि इलेक्ट्रॉन का चार्ज आपको मालूम है 1.6 10 minus 19, उसका मास क्या होता है 9.1 10 minus 31. अगर मैं इलेक्ट्रॉन और प्रोटॉन ले लूं तो यहाँ पे Me MP हो जाएगा, चार्ज तो सेम रहेगा, ये हो जाएगा Me into MP. मास ऑफ प्रोटॉन, मास ऑफ प्रोटॉन 1.67 into 10 minus 27. 1.67 into 10 minus 27. When you put this value here, you will get this ratio. Fe by Fg as 10 to 39 of the order of 10 to 39, and this is calculated in detail in NCERT book, page number 13. Okay, so this was also a very good property of Coulomb force, that Coulomb force is a strong force. Now next property, Coulomb force is a short range force. Is a short range force. बहुत कम डिस्टेंस पे भी एक्ट होगा ये, राइट? बहुत कम, न्यूक्लियर के डिस्टेंस में भी कम होगा. जैसे 2 प्रोटॉन को अगर आप 1 फर्मी के डिस्टेंस में रखेंगे, 1 फर्मी मींस 10 to minus 15 मीटर. At this distance, if you take 2 protons, और याद रखें न्यूक्लियस के अंदर में जो प्रोटॉन्स होते हैं इसी डिस्टेंस पे होते हैं विद इन द न्यूक्लियस. द प्रोटॉन्स आर सेपरेटेड बाय नियरली 10⁻15 meters, 1 Fermi distance. And these two protons, what would be the force? The force निकालेंगे तो क्या होगा? 1/4 pi epsilon naught E by r square. वैल्यू रखिए 9 10 for 9 E 1.6 10 - 19 दो बार आएगा. r square 10 - 15 square. ये लगभग 230 न्यूटन के आसपास आएगा. समझ? तो ये जो क्वेश्चन है ये आप एस सी वर्मा की बुक देखिए, पेज नंबर 121 पे क्वेश्चन नंबर 5 है. 230 न्यूटन ये आंसर आएगा. ठीक है, ये आप एनसीईआरटी के सेम पेज को देखिए, पेज नंबर 13, वहां पे बीच में लिखा हुआ कहीं पे कि दो प्रोटॉन जो है न्यूक्लियस के अंदर में जब होते हैं तो कितना रिपल्सिव फोर्स लगाते हैं. तो व्हाट रिपल्सिव फोर्स द न्यूटन दिस टू प्रोटॉन्स विल एक्सर्ट विद इन द न्यूक्लियस के अंदर में ये 230 न्यूटन का फोर्स लगा सकते हैं when the separation between them is 1 Fermi, that's -15 meters. You can put the values and you can calculate, you will get the same 230 Newton. Okay? लेकिन याद रखिए वहां पे एक और फोर्स लगता है. कौन सा फोर्स? न्यूक्लियर फोर्स, जो कि ज्यादा स्ट्रांग होता है. तो प्रोटॉन रिपेल करने की जगह अट्रैक्ट हो जाते हैं क्योंकि न्यूक्लियर फोर्स वहां अट्रैक्टिव होता है. याद रखें 0.8 फर्मी से कम डिस्टेंस होने पर, कितने पे? 0.8 फर्मी से कम होने पर जो है याद रखें कि प्रोटॉन्स एक दूसरे को रिपेल करने की जगह अट्रैक्ट करते हैं क्योंकि 230 न्यूटन से भी बड़ा फोर्स होगा. कौन सा फोर्स? न्यूक्लियर अट्रैक्टिव फोर्स between the two protons. Okay, then only the nucleus is stable. Okay, मैं जो क्या होगा, प्रोटॉन उसको रिपेल कर देते हैं. हाँ, जो हैवी न्यूक्लियस होते हैं, जो बड़े न्यूक्लियस होते हैं, उनमें प्रोटॉन और प्रोटॉन के बीच का डिस्टेंस ज्यादा होता है तो न्यूक्लियर फोर्स कम हो जाता है और रिपल्सिव फोर्स ज्यादा हो जाता है. इसलिए हैवी न्यूक्लियस जो है इसी रिपल्सिव फोर्स के कारण स्प्लिट हो जाते हैं क्योंकि ज्यादा डिस्टेंस पर न्यूक्लियर फोर्स काम नहीं करेगा. न्यूक्लियर फोर्स एक्सपोनेंशियली वेरी करता है. ओके, बहुत जल्दी डिक्रीज होता है. So this was a good property. Now next property. Coulomb force is a conservative force. याद रहेगा? Next property is what? Coulomb force is a conservative force. Conservative force, when work done by a force or work done against the force, it does not depend upon the path followed. Okay, when work done by the force or work done against the force, it does not depend upon the path, then such a force is called what? Conservative force. Right? तो अगर आप कंजर्वेटिव फोर्स कंजर्वेटिव फील्ड में है, एक पॉइंट से दूसरे पॉइंट में किसी भी रास्ते से जाइए आप, you follow any path, the work done is always same. So when you move against the force, following any path from one point to another point, the work done does not depend upon path. Whatever path you choose, the work done is always same. एक और चीज याद रखिए, अगर कंजर्वेटिव फोर्स है तो अगर आप एक पॉइंट से स्टार्ट करके वापस अगर उसी पॉइंट में आ जाते हैं, if you move a charge in a conservative field from one point to another point and following a cyclic path, if you return back to the same point, then the total work done is 0. So work done for a closed path. What? Work done for a closed path in the conservative field is always 0. Okay. So Coulomb force भी conservative force है, याद रखें. Next property. Coulomb force एक central force है. कैसा force है बच्चों? It is a central force. It acts along the line joining the 2 point charges. ये जो 2 point charges होते हैं उनके along, उनको जोड़ने वाली लाइन के along एक्ट होता है. सेंट्रल लाइक चार्जेस के लिए रिपल्सिव, अनलाइक के लिए अट्रैक्टिव. ओके, उनको जोड़ने वाली लाइन के along, it acts along the line joining the centers of the charges, right? Okay, central force. और जितने भी central force होते हैं वो जनरली इनवर्स स्क्वायर लॉ को फॉलो करते हैं. Okay, so these are some very important properties of what Coulomb's force. So this we have studied about what Coulomb's law, its properties. In the next lecture we'll be dealing with what? Its numericals. Okay students, so watch the lectures in sequence. You will get the lectures of the whole syllabus in what sequence. Okay, तो अगर आप sequences को देखते जाएंगे तो आपका concept बहुत अच्छा होता जाएगा. So next lecture में मिलते हैं. There will go through some important properties, some important numericals of what Coulomb force.